What if the oranges you consume every day is not as clean as it seems? Hey everyone! Hi, I'm Ain Adrini and I'll be the first person to tell you how science makes sure that orange juice is good. People all around the world love oranges because it has a lot of vitamin C, flavonoids and other important nutrients. But if not carefully regulated, it can potentially be mixed with other substances or contaminated. That's why it's crucial to do a good job of analyzing. Scientists can find important nutrients like vitamin C and undesired preservative or pollutants using high performance liquid chromatography, which is HPLC. HPLC is very important for making sure that fruit juices are safe, real, and reliable as demand for them grows. Next, the objective of this study is to use HPLC to measure the amount of pollutants in oranges to check food safety. Next, look at the nutritional quality of important nutrients like sugars, acids, and vitamin C. Lastly, check that the approach is correct for following rules and making sure the product is real.
Now, for the methodology part, high-performance liquid chromatography, or known as HPLC, was used to quantify vitamin C, organic acid, and carotenoids in orange juice sampled from different processing types, such as hand-squeezed, fresh industrial, and pasteurized industrials. Materials and equipment that needed to run this process are HPLC system with UV detector, C18 reverse phase column, 0.1 phosphoric acid for stabilizer or mobile phase, 0.45 micrometer syringe filters, volumetric flask, centrifuge, and pH meter. Now we move to sample preparation procedure. First thing first, we need to blend fresh oranges or use ready juice. Then we centrifuge 10 mm at 5000 rpm for 10 minutes to remove pulps or seeds. Secondly, we adjust the pH of 5 mm supernatant to 2.5 with 0.10 phosphoric acid. Then we dilute to 25 mm with 0.1% of phosphoric acid in the ratio of 1 to 5. And finally, filter through 0.45 micrometer syringe filter. And we transfer it to HPLC vials. We must remember that we need to use the fresh prepared one. For making sure that the quantification of this orange juice process to run perfectly, we need to follow the HPLC condition as shown here. Then, for the data analysis, we must identify peaks by retention time. For ascorbic acid, it is approximately 3 to 4 minutes. Then we quantify via external calibration. Then we use peak area for concentration via linear regression. Do you know why we need to follow these steps accurately? It is because this version eliminates vagueness, add quantifiable steps matching validated protocols, and ensure column safety and reproducibility. It directly supports your results on the table of vitamin C and carotenoids. Test with a standard before finalizing it.
Then I will explain the methodology in this diagram. This diagram shows how an HPLC system is used to analyze orange juice for nutrient content and food safety. The process begins with the solvent reservoir, which contains the mobile phase. The HPLC pumps maintains a steady flow rate while forcing the solvent into the system at high temperature. Next, the injector is then used to inject the orange juice sample into the solvent stream. When the sample enters the column, chemicals are separated based on how they interact with the stationary phase. After being separated, the compounds go through a detector usually a UV detector, which measure them and give signal in the form of peak. The data collection system analyzes this signal to produce chromatograph for qualification and identification. Finally, the solvent is released into the waste container. So, by using HPLC, we can accurately measure nutrients such as vitamin C and sugar while also checking for impurities to ensure that the juice is safe and fulfill quality standards.
So here the result what we can get. So first image is a prediction time of the vitamin C regression in range with orange juice samples. The mean value of commercial sample is higher in organic color. Next is a table 3, which is a content of stable mg per liter and retinal activity events in the orange juice analyzed. So this is a chromatogram at 450 ml of the content extract from the sample. Next, the features chromatogram and calibration curve of standard vitamin C, uh, citric acid, and nitric acid. So for the content, the orange juice typically contains approximately 43.61 mg per 100 gram of vitamin C, which is significantly higher than other citrus fruits like lime or grapefruit. So next is citric acid is the predominant organic acid, and sucrose is the major sugar found in commercial juice. For stability, its research indicates the vitamin C in fresh squeezed juice remain roughly 33% higher than in commercial pasteurized version by the end of their shelf life. So the HPLC analysis show clear and well-defined peaks corresponding to vitamin C and natural sugar such as glucose and fructose. Fresh orange juice contain higher vitamin C levels compared to packaged juice. No harmful chemical contaminants were detected within the test limits, indicating that the sample were safe for consumption.
Now let's move on to the discussion part. The results confirm that orange juice is a rich source of vitamin C, supporting its nutritional importance. The detected levels of preservative within recommended safety limits, indicating that the product is safe for consumption. HPLC proved to be an effective technique due to its high sensitivity, accuracy, and ability to analyze both of the nutrients and food safety parameters in a single sample.
So, in conclusion, the HPLC study supported the nutritional value of orange juice by proving that it contained important nutrients such as vitamin C, organic acid, and natural sugar. The juice is safe to drink and correspond with food safety regulation since no dangerous chemicals exceeded safety limits in any of the tested samples. In addition, the result showed that fresh orange juice had more vitamin C than processed juice. Any identified preservative and additive remain within the regulated safety limits, verifying the quality and consumer safety. Overall, HPLC demonstrated an effective method for analyzing both nutrients and safety components in orange juice in a single run.